Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD Firdaus Farihin. So, I will introduce the introduction. The rice transplanter 2ZG8D2K represent a significant advancement in agriculture machinery, specifically and designed to streamline and enhance the process of the rice planting. Developed with a cutting-edge technology, this transplanter integrates efficiency, precision, and sustainability into rice cultivating practice. This set the stage by highlighting the key features and benefits of the rice transplanter, emphasizing its role in modernizing agriculture practice and improve productivity in rice farming. So for the tractor, we used a Kubota DC99G. It's a high-performance rice transplanter designed for efficient agriculture operation. Known for its robust build and advanced technology, the DC99G is equipped with a powerful engine and wide working width, making it ideal for large-scale rice planting. It features an advanced seedling transplanting system that ensures uniform planting and high productivity.
Next, we go to the computational method. Computational method has 5 steps. First is identify the operation. Step 2 is make an assumption. Step 3 and 4 determine machinery capacity, number, and size of machine tractor. For step 5 is compute cost analysis. For the step 1, identify the operation. We use two tools in one tractor. First is rice transplanter for transplanting. Second is combine harvester for harvesting in paddy area. For step 2, make an assumption. For the rice transplanter, the model we use 2ZG8D2K. For the coverage area for rice transplanter is 500. Working days is 60 days. Working hours is 8 hours per day. Total working hours is 480 hours. The speed is 0.5 mm per second or 1.8 km per hour. The efficiency is 75%. Power cost is 1 kilowatt equal to Rm 1000 ringgit. The force is 12 kilonewton. For combine harvester, the model we use DC99G. The coverage area is 500 hectare. Working days is 60 days. Working hour is 8 hours per day. Total working hour is 480 hours. For speed is 1.5 mm per second or 5.4 km per hour. For efficiency is 75%. For power cost is 1 kilowatt equal to 1000 ringgit. For the force is 15 kilonewton.
For determining the machine capacity as shown in the slide number 7, this is the detail for each of the machines. So in order to calculate the machine capacity, we must calculate the TFC first, and the formula that we use is speed times with the width divided by time. After calculate the TFC for rice planter is 0.6426 hectare per hour. Meanwhile, the answer for rice harvest is 1.0683 hectare per hour. After that, we must calculate its EFC, which is TFC times with the field efficiency. For rice planter, after the calculation, the answer that we get is 0.48165 hectare per hour, and for rice harvester is 0.8012 hectare per hour. The last method that we need to do is we must calculate its required EFC, and the formula that we use is area divided by time. Both of the machinery have the same required EFC, which is 500 hectare divided by 480 hours equal to 1.42 hectare per hour for both machinery.
Alright, for the step 4 is to determine the number and size of the machine or the tractor. First, we calculate for the rice transplanter. First, we want to identify the working width. The formula is EFC time with 10 divided with the speed, and time with the 100 and divided with the FE. The EFC is 1.042, the required EFC, and then the speed is 3.6 km per hour, and the FE is 75. So after calculation, we get the width is 4.54 meter. For the required power, the formula is force time with the speed and divide by 3.6. The force is 12 kN and the speed is 3.06 km per hour. After calculate, we get the power is 10.2 kilowatt. Next, for the total area cover by one machine, first we need to calculate the working hour. The working hour is 60 days, time with the 8 hours per day, and we get 480 hours. So the formula is machine EFC, time with the total working hour. The machine EFC is 0.48165 hectare. So after we calculate, we get the total area covered by one machine is 231.192 hectare. So the number of machine needed, the formula is total area one machine can cover divide with the total area need to be covered. So 500 hectare divided by 231.192 hectare, we get 2.2. Since the machine needed is 2.2, so the model required is 3 machines to conduct the entire operation. Next, for the rice harvester, for the working width, the EFC is 1.042, the speed is 5.4, and the FE is 75. After calculate, we get the width is 2.573 meter. For the required power, the force is 15 kilonewton, and then the speed is 4.896 km per hour. So after we calculate, we got the power is 20.4 kilowatt. The total working hours still the same, which is 480. So the total area covered by one machine, the EFC is 0.8012 hectare, time with the 480. So we get the total area covered by one machine is 384.576 hectare. So the number of machine needed is 500 hectare. We divide with the 385.576 hectare. So we get the answer is 1.3. Since the model required, since the number of machine needed is 1.3, so the model required is 2 machines to conduct the entire operation. So in conclusion, I can say for rice transplanter we need 3 machines, and for rice harvester we need 2 machines to conduct the entire operation.
Let's move on to step 5, cost analysis. We will be examining both the fixed and operating costs associated with 2 pieces of agriculture machinery, the rice transplanter and the combine harvester. The cost analysis for the rice transplanter and the combine harvester reveal that the initial purchase price for the rice transplanter is 18,500, which a total of 55,500. Depreciation is assumed at a 10% rate, resulting in 5,550 per year. The total system integration insurance (TSII) is assumed at 12%, resulting in 6,660 per year. The total fixed cost for the rice transplanter is RM12,210 per year. Okay, the combine harvester has an initial purchase price of 70,300, which a total of 146,600. Depreciation at 10% result in 14,660 per year, which TSII at 12% adding 17,572 per year. The total fixed cost for the combine harvester is 32,252 per year. Okay, the operating cost for the rice transplanter are calculated as follows. Fuel cost is RM41.46 per hour. Fuel and lubricant are 45.60 per hour. For the repair and maintenance are RM6.66 per hour, and labor cost is RM15 per hour. The total operating cost for the rice transplanter is RM67.26 per hour. Okay. For the conclusion, understanding the fixed and operating cost of both the rice transplanter and the combine harvester is crucial for effective budgeting and operational planning in agriculture management. We continue with step 5, cost analysis. Let's now examine the total cost per hectare and our long-term plan for machinery replacement. We will also look at the break-even point for owning the machinery. The total cost per hectare for the rice transplanter and the combine harvester is calculated by dividing the fixed cost of 12,210 by 480 hours, giving RM25.48 per hour and RM92.74 per hour respectively. The total cost per hectare for the combine harvester is Rm 220.28 per hour and Rm 229.19 per hectare. To maintain efficiency and cost effectiveness, the strategy involves replacing machinery at a crucial interval. For example, 3 rice transplanter with 18.5 and 2 combine harvester with 73.3 should be replaced every 10 years. To set up an annual reserve fund, the replacement cost divided by the lifespan is calculated, resulting in an annual reserve of 2,210 per year. In 10 years, the company will have 2,100 saved to replace this machine. The break-even point (BEP) for the rice transplanter and combine harvester is determined by dividing the total annual fixed cost by the contribution margin per hectare, which is approximately 111 hectare. The total annual fixed cost divided by the contribution margin per hectare is approximately 293.2 hectare, and the combined harvester needs to cover 293.2 hectare to break even. In conclusion, the total cost per hectare and the break-even point for both the rice transplanter and combine harvester are analysed to understand the minimum operational scale needed to cover costs. That's all for me. Thank you.
Assalamualaikum. So I will conclude for this case study, which is between the rice transplanter and the combine harvester. So we have first of all, I will explain about the EFC, which is for the rice transplanter we have 0.482 hectares per hour, while the combine harvester we having a 0.8012 hectare per hour. For the fixed cost for this machine, we have the rice transplanter, we have 12,210 for each, including annual depreciation and insurance, while the combine harvester we have 32,252 ringgit each, including annual depreciation and insurance. So the operating costs for using rice transplanter over 500 hectares are approximately 67.26 ringgit per hour, which is it also covering fuel, lubricant, labor and maintenance costs. So same goes to combine harvester. We also have the operating cost, which is 211.39 per hectare. So we go to the BEP, which is the break-even point. So for the rice transplanter, we have the 111 hectare, requiring the machine to collect at least 111 hectare for fresh fruit bunch, which is the FFB, annually to cover all fixed and variable costs. The combine harvester, on the other hand, requires continuous operation at least 293.2 hectare annually to cover all fixed and variable costs. So, if you use this machine and maintain properly, the rice transplanter and the combine harvester can be a cost-effective investment for paddy production.